Okay, so in this problem here, they want to know, oh, here's angle 1, and here's angle 2. And they also, I need to label a couple things I forgot to label. KLM, KLM, and we also need to do JON. Okay, so they want to know which of these four, I wrote the reasons to the right here, which of these four, one of these you will not use to show that angle 1 is congruent to angle 2. Okay, so you're trying to think about the proof and how you might do it. Okay, and so what I might do is to somehow show that this triangle is the same as this triangle here. Okay, well, I only have a set of sides in that situation there, so it's not going to be that easy. So I'm going to go back up and go, okay, can I get some information by showing this triangle is the same as this triangle here? And maybe there's some parts that will match up, and then I'll get some more information. So let me do some of that right now. And so the first thing is, I noticed that in those second two triangles I was pointing out, this is the same. That's a side. Okay? And I also noticed that there was this right angle here and this right angle here, and that's touching that yellow one, so there's an angle. Okay, and then I noticed another set of angles right here and here that are on the other side. And so it looks like that, if I outline it in green, this triangle LJO is congruent to triangle LNO by ASA. So I'm going to need ASA, and I also used the reflexive property when I did the yellow piece right here. So I've already got two things that I've used. Okay, now it turns out that we also know then that this angle is the same as this angle right here by CPCTC. And it also means, and I'm going to do this one in purple, it also means that this angle here and this angle here are the same. Why are they the same? Well, in angle J or in angle N, in J or N, the two angles have to add to 90 degrees. The red one and the purple one have to add to 90. So purple plus the red angle have to equal 90 degrees. This should be a 90. Okay, 90 degrees. Another word for that is they are complements. Okay? And it turns out that they are going to be congruent complements because they're both using an angle that's the same size as another angle. So when you subtract them from 90, when you subtract the red from the purple, when you subtract the red from the 90 degrees, you will get the same answer in purple. Okay, well that's called the congruent complements theorem. Once we know that, we now have, we also have that this side is the same as this side by CPCTC. So now we can show that the triangle, I'll draw this in yellow, this triangle here and this triangle here are the same by S from here. We've got the angles right here in purple, A, and then we were given the side here. And by showing that those triangles, the two yellow ones that I drew in there, are the same by SAS, we then can say that angle 1 is congruent to angle 2 by CPCTC. The corresponding parts on congruent triangles, the yellow triangles are now congruent, on congruent triangles are congruent. What we did not use was this. So this is the one that they want you to choose, because that's the one you are not going to use in this kind of lengthy proof.